Hey guys, it's Greg Jones with Engine Builder. Today we're in Houston, Texas, and as you can see, we're at Late Model Engines, and owner Bryan Neelen has been kind enough to let us come in and take a shop tour and check out all the cool things that they do. So follow me, let's go inside. All right, guys, well, we're inside Late Model Engines. I'm joined by co-owner Bryan Neelen. Bryan, thanks so much for having us in today.
Absolutely.
Yeah, you know, you and I have had plenty of conversations over the years, and you guys even did an Instagram takeover tour with us a few years back.
That's fun.
Which maybe some of the viewers remember, but we're going to do this tour even better than that one.
Okay.
So I've never been here in person, so I'm pumped to see inside. I know you guys do a ton of cool stuff. You guys have been growing. You're celebrating your 20th year in business, so lots of things going on, right?
Yes, sir. We got a lot of stuff going on. We've brought in some new machinery this year, some of what we've already had, and some new pieces as well. So we're looking to build some new products that we've never been able to have the capabilities of doing previously. So we're just getting ramped up here. Yeah.
So before we walk around and see in the main shop, let's set it up for the folks. You know, how many square foot?
Sure. So this is roughly 17,000 square foot.
Okay.
We have 5,000 square feet of office and assembly room, and then roughly 12,000 of manufacturing area.
Awesome. And then how many employees do you guys have?
There's currently 27.
Okay. Yeah. Big operation you guys.
Yeah, we got sales department, marketing. Doing a lot of R&D and engine builders, CNC machinists, cylinder head machinists. So when we all work together, it's a beautiful thing.
Absolutely. Without further ado, let's see it.
Yeah, so
I'll let you lead the way.
Yep. So we do a lot of our marketing and that type of stuff, website development work in there, pictures and stuff. But we've been actually stocking some in-stock short blocks. So they've been moving really well. Yeah. That's something that we're trying to transition a little bit more to is having product in stock.
Sure.
Mainly short block cylinder heads. So, taking the lead time down on our, standardized, proven combinations.
Right.
So right now we're focusing on a lot of the LT, been really popular, just to help customers out. I mean, name of the game is delivery time.
Yeah,
so
absolutely.
When we can get something that's, offered on our website in, shipping same day or next day, that's what we're going for. So we've got a bunch of, 416 LT 390s, 427s in stock ready to go.
Yeah. And Bryan, obviously folks will see once we get back there, you guys are doing a lot of machine work, a lot of different engines coming through, but break it down for us, how many engines come through the shop in a year, in a month,
so we're doing over 500 engines a year, 400 to 500.
Yeah.
That's comprised of short blocks, long blocks. So, obviously the turnover rate on a short block is a bit more than a dyno tested long block. So on an average, about 600 sets of cylinder heads. So we're sending cylinder heads all over the world just as heads only, heads cam packages. We supply a lot of the, name brand installation performance shops with their cylinder heads. So that's been really good as far as just repeat business, bread and butter type stuff. So it's awesome.
Awesome,
and then,
Cool.
So it's a little area where we assemble intake manifolds and our front cover kits, a lot of our machine products. So there's an example of a LS7 billet intake manifold.
Yeah.
This thing's been one of our parts that we've had for a number of years now. So we love this, makes great power. Starts out as 234 pounds of aluminum, ends up as 22 when it's done. Takes about 20 hours of machine work.
Yeah.
56 stainless bolts, all dovetail O-ringed.
Wow.
So
that's cool.
This one's anodized black.
Yeah.
But fits under the hood of a Corvette F body. That was kind of the driving force for this manifold, or what its need was. We were building tons of LS7 engines, and none of the manifolds that could handle boost or make good power could fit under the factory hood. So this one just sneaks right under the factory hood and works like a champ.
Now, personally, are you an anodized fan, or do you like the raw aluminum look?
I like the raw aluminum. You know, it's a pretty cool when we can do some like contrast, you know, stuff like that. You know, the logo, it helps the logo pop for sure.
That's true.
But, you know, seeing the tool pass, the anodized I like, and we do some of the powder coating, you know, it does cover up some of the tool mark, you know, some of the tool pass. So when you can see all that, I mean, as a machinist, that's what I like to see.
Yeah, for sure.
But yeah, we've got a lot of our LT front covers, valley covers, different valve cover combinations that we make, LS, LT, both short and tall.
Yeah.
Our new, this product's been really good for us. This is our LT billet valley cover.
Yeah.
It's got a baffled -12 AN fitting, so you can go right to your catch can as opposed to going off the factory valve covers.
Yeah.
Just works out really nice. It's a beautiful piece.
Yeah, absolutely. No, everything's really, really nice.
So yeah, can show you the assembly room and machine shop.
Yeah.
I don't. I do my best to avoid that.
So we have
Hey guys.
the ability for 7 engines to go together at one time. We got 5 stations in here, 2 in this other room.
Yeah.
Production manager and purchasing manager's office in there. So yeah, we got a great group of guys, lots of talent. We all get along real well, and you know, just hanging out building engines. So it's really good.
So you got 3 or 4 guys in here full time.
There's 6 guys assembling engines full time.
Okay.
And then when our production manager has time to get behind the assembly table, he does that as well. That's our 7th. So
nice.
Yeah.
That's awesome.
Got a lot of stuff going together. LSX block. This is a new LTR block. So this is kind of one of the cool pieces that are out. So that this is cast and machined by Concept Performance. They've been doing the LSR for a number of years, and now it's the LTR, essentially a 6-bolt version of the LSR block.
Yeah.
Building a ton of those. This is the 440 that we're going to show you here in a little bit, is based off of this. So we're using this for anywhere from a 4125 to 4185 bore combinations. Typically used in a majority of boosted applications. We do our 427 and our 400 cubic inch combos out of this, either both 1400 or a 2000 horsepower combo.
Yeah.
But the one that we just built in Dyno today was a 440, 4185 bore with a 4-inch stroke, 12.5 to 1 compression, naturally aspirated setup for a road race application in a Camaro.
Cool. Yeah, and I understand. Might get some more info on that particular build for an engine of the week.
Yeah, for sure. So yeah, this is our clean room. Do all of our measurements, assembly, everything in here.
So Bryan, you know, do certain guys only handle certain combos, or is everybody kind of just sifting through on a first come first serve basis?
That's pretty much. I mean, we have you know, each of our builders has, you know, a real vast capabilities as far as what they can handle. So we're
everybody does it all.
Yeah, basically.
Yeah. Cool. Cool. All right. Yeah, I always love seeing the assembly room. Yeah, it's where everything's coming together.
Exactly. Show you the machine shop.
Wow.
Yeah, as far as you know, guys working on stuff. I mean, we have everybody has their. We have a very broad spectrum of guys that experiences. So you know, a lot of NHRA Pro stock, circle track experience. So when some projects come along, you know, there's always like, hey, we want that guy to build it.
Yeah.
But as far as, you know, all of our proven combinations, anybody can handle any of the jobs.
Yeah.
So, and that's one of the things that we really have worked towards over the last, you know, 20 years is a standardized process. So if, you know, Jim builds it, Vinny, or you know, whoever builds it, it's the same product, and that's really what we're going for. It's not like, oh, you know, Jim built this one and it looks like this, it's done that way.
And that's crucial when you're doing 500 engines.
Exactly. So it's really following and doing the process, keeping to our standardized process, which makes consistency throughout. So it doesn't matter if you know who builds it; it's all the same. Late model engines. Engine.
All right, so Bryan, you're saying this is 12,000 square feet. And for folks back home, you know, you guys are just watching it, but I can literally smell all the machining going on. It's a cool smell, actually. I mean, there's a ton going on back here. So yeah,
sir.
take it away.
All right. Well, I'll set you up. We'll go through our process a little bit, and that's the easiest way to kind of show you all the different pieces.
Cool.
Do our small package shipping and receiving through here.
Okay.
We ship engines out in this location here. All these engine carts are just projects in process, rebuilds. All projects that are customer builds in process.
Yeah.
A bunch of new block inventory here. Got a shipment, a ton of dart blocks in. But this is where we do our tear down and disassembly work, if that's going to be done. So a majority of our builds are brand new builds, but we do quite a few rebuilds. So supporting current racers, current customers on refreshes. We do quite a bit of work where, you know, a customer has, you know, just engine rebuilds, you know. A lot of LSXs and dart blocks, race engines that we'll rebuild. Even if we haven't built them originally, we can take on that work and get it race ready again.
Yeah.
So back here we'll do the line hone or line boring if needed. So this is a Hemi block that we have set up in the Burco.
Yeah.
It's going to receive billet main caps, and so once we machine it for the billet caps, it'll come to the line hone. So this is the first setup of any quality blueprinting process, right? As most of our colleagues know.
Right. Yeah.
Right. So establishing the center line of the mains is crucial. Also getting the geometry, dialing in your bearing crush. So we have a very specific number that we like to use for our LS or for all engines to get that bearing crush where we feel it should be. You have your manufacturer's recommendations, but we've found that sometimes we have to deviate from that just a little bit.
Yeah.
So your basic line hone, getting all of the main housing bores in line and at the right size.
Yeah.
So once we're done back here, we'll go over to the 4-axis CNC and do the rest of the machining on that.
Right.
This is our old cylinder hone that we've had since the beginning. We just do our lifter bushings. Once we'll hone lifter bushings. If we ever need to hone something that doesn't fit within the realm of what our current diamond hone setups, we can hone with this, like have an oddball deal.
Yeah.
Also do our cleaning back here.
Okay.
So we have a jet wash for our initial cleaning, as well as an ultrasonic. Your Varsol tanks, all that. So the initial cleaning goes on here, and then our final cleaning is done in a different part of the shop for later in the process. So once the align hone's been done, we'll come over to the 50 taper 4-axis machine. So right now we're surfacing the deck of the block. Since the line hone has been done, right? We've established our center line of the mains. We then have, we go into the 4-axis here, and we center off of the center of the mains and the center of the cam. So we have lugs that go into those two registers on the block. That slides in, and then our center of rotation is the center of the mains. So if we're shooting for like a 9240 deck with a 4125 bore, 1/2-inch studs, we'll call up these pre-programmed programs that we've already input into the machine,
right?
And basically select all of the processes that are needed for that combo based off of the sales order.
Yeah.
So our machinist will come in, will run those programs, and then it'll be off to the cylinder hone.
Yeah.
But yeah, we have this set up. We do all of our receiver grooves for the top fuel hoops, lifter bushings, 1/2-inch studs, clearance for the stroke, decking and boring, of course. What else? We'll do our Jessel belt drive program on here.
It's doing a lot of things.
Pretty much anything you want, yeah. So it's nice when you can put the block up in there, like especially like an LSX block. We'll bore from I think it's like a 3990 to a 4120 bore in one pass.
Wow.
So we've got a double-headed boring head.
Yeah.
With this machine here, it is a 50 taper with a 2-speed gearbox. So that helps give it power at a lower RPM for boring.
Yeah.
So sometimes with the 40 taper machines, they don't have enough torque down low run a boring head like that. So that's one of the reasons we selected this machine.
Yeah, and this isn't that old, right? This is just a couple of years old? Or?
This machine's like, I forget what this one is. It's maybe a 2008, something like that.
Okay.
It's got a few years on it, but we don't pull this fixture out for anything else but doing engine blocks.
Yeah.
So we're not, constantly moving this machine. It just kind of goes and does its own things, purposely for just machining engine blocks.
Right. Very good.
Whereas I can show you a little bit more here in a minute, but the machine behind us is going to be geared more towards actually creating a billet block as opposed to just machining a casting.
Right.
Or how like a GM block or a dart block that already comes basically pre-machined, and we're just dialing in bore size, deck height, and all of that.
Right. Very cool.
So we'll get back to the CNC machines, but I'll show you the rest of the standard engine building equipment that we have.
Sounds great. Now, Brian, I noticed on the carts, it's not necessarily one cart per customer. There's even like different customers per shelf because you guys got so much going on, right?
Yeah. So I mean, if it's just a short block build, we're not going to devote a whole cart to that. So we've got there's many engines to be built.
Absolutely.
So back here is where we do all of the rest of the engine machining. We've got a little fab area, do some welding and cylinder head repair. He's welding on a pickup tube right now, making something custom.
Yeah.
We have 2 cylinder hones that we run. We were just talking about the Rottler a couple months ago, right?
Yeah.
So
this is a pretty new machine for you guys.
Yeah, that we've got. We purchased that, put it into use this year.
Okay.
So it runs like a champ. We're doing a LT iron block right now for one of our 1800 horse packages.
Yeah.
And so we set it up. We put two torque plates on it so we can switch back and forth to each bank more quickly.
Yeah.
So this thing's been really good. So once we come off the CNC, we've got our main housing bores. Boring is done to the size to hone. Deck height's established. So the last process really is the honing of the block. Once we come out of this machine, we'll go down into the cleaning room, and I can show you a little bit of that. So here, all of these blocks are in different processes of the machining process, but we've got quite a lineup.
Yeah.
Majority of these are already finished machine, waiting on assembly.
Okay.
Yeah. Got your crankshaft balancer.
Yeah.
We've had this thing for a while. It's a Heinz balancer, industry standard. I mean, we really like the Heinz balancers.
Yeah.
It's been really good to us. Pretty standard stuff there.
Very cool. Yeah, and that's all done here in house, and
Yep, all the balancing. We devoted this mill here. We devoted this mill here to putting in the heavy metal. So we'll machine for the slugs here. Put it up into this press. We got a little hydraulic press that we press the tungsten in with.
Yep.
And then right back to the machine.
Yeah. Excellent.
Yep.
Excellent.
Yeah, nice setup. And then we'll do our crankshaft polishing. That's one thing that we've really spent a lot of time figuring out and dialing in is surface finishes all throughout our build process.
Sure.
So, it's just critical with all the modern engines is surface finish on, your not only your main and rod journals, but your surface finish on the deck, cylinder hone finish. But we've spent a lot of time to dial in, and we were able to get our cranks to a 2RA or better, and we feel like that's about for the realm of money that can be spent. 2RA is really good.
Yeah.
To go smoother than that seems to be, it's kind of a diminishing return in
Right.
the sense of financially and how much time you're going to put into it. But 2RA is very good for engine life and performance.
Yeah.
So we have another mill here that we do our, if we're cutting valve pockets or just general machining on different stuff as opposed to the other Bridgeport here.
Yeah.
We have a surfacer that's devoted for engine blocks. So if it's something we're not going to put into the CNC, we can do one-off surfacing of
if that's the only thing that's
right. If
getting
we're
done to
only
it.
decking it, or if it's a block that we don't have a fixture for the CNC.
Yeah. Okay.
Sometimes if you're just doing one block, it doesn't make sense to to devote all the
Right.
CNC to that,
Right.
or if it's running more parts. So this will just do engine blocks, and then we have another surfacer for just cylinder heads. But I can get into the cylinder head process here in a bit too.
Okay.
Once the engine block has been deburred, final deburred, and inspected, it's passed all of our QC in that regard.
Right.
We'll come into this room to finish clean the block. So we jet wash it, then we'll swing it over, final rinse it, brushes, and get it to where it's nice and finished clean.
Yeah.
We'll finish that process actually in the assembly room with lacquer thinner, ATF, to get the cylinders as clean as we possibly can. So we're a very big believer in the cleanliness of the build throughout.
Oh, absolutely.
You can do the best machine work in the world, but if you're leaving debris in the crosshatch of the cylinders or in the oil galleys, I mean, obviously you're not going to have success. So final cleaning of the block is critical. We spend a lot of time getting all the components and block as clean as possible.
Yeah.
So that's essentially your engine block machining process. As far as the cylinder heads go, we tear them down in the back just like we do the engines. I can show you the CNC equipment for the porting.
Yeah. Bryan, how long does it typically take a block to go from, getting cleaned, into the shop, getting cleaned, and then through all the machining process we just talked about?
So if we're
what's
just,
kind of that standard time frame?
Yeah, I mean, if we're just running a block, I mean, we can take a block from the line hone through the CNC and through the cylinder hone in just a matter of, say, 4 hours.
Okay. Yeah.
Something like that.
Yeah.
Depending on how many machining processes are done in there, but we can deck, bore, clearance for stroke in about an hour and a half.
Okay.
Which is
pretty quick. Yeah.
Under 2 hours.
Yeah. Awesome.
So once we'll tear down the cylinder heads. If we're going to install guides, if it requires guides before porting, that'll be done back there. We're currently running 2 5-axis machines that are doing our porting. We just took on delivery of another Herco like last month. So that one's just about to get into operation.
Okay.
But we run primarily in the Herco here. We'll run the raw castings to the finished part. And the Centroid is more devoted to running the factory castings that we're CNC porting.
Okay.
So we do a ton of that work where either the customer end user or the installation shop will just send us the factory castings, LT1, LT4, LS7, whatever it might be.
Yeah.
The new Hemi stuff, and we'll do like a core exchange program to where, we can send them the finished cylinder heads. We'll get their cores back after they pull them off, and then they can have everything in hand when they go to do the actual job. So they're not waiting on us to turn around the cylinder heads. So this machine primarily does that. It's got some pretty good movement right now. I mean, I love the 5-axis.
It is pretty neat.
It's badass,
so it does stuff that you don't think like it's possible, right?
Exactly, and we do all of our programming in house. So we started off doing digitizing the hand ported head. Yeah. And we've kind of evolved to doing a majority of our ports in CAD only. When we're privy to having the model, the water jacket model and the full casting model of the cylinder head, that allows us a lot more freedom to create a port that really optimizes that casting. So we've been doing that primarily. It just results in really nice surface finish. Like whatever you get from digitizing can never be as nice as the actual surface that you're able to create than if you're creating it in just CAD. Yeah. So we've evolved in that way. But these are some castings from Edelbrock. This is a really good seller of ours. This is the LT, what we call our LTX race head. Has a straight exhaust port as opposed to a dogleg port of the factory LT. We set this one up with a 2180 intake and 1630 exhaust. And that will fit on a 4070 or 4065, 4070 stock bore on an LT. Just really optimized. We kind of moved around and played with the guide placement, valve spacing and placement on it. And we feel it's the highest flowing or most power potential for any aftermarket LT head.
Now, these castings will all turn out to be the exact same head, or like how many different combinations do you guys have of just that? We've
pretty much gone all in with just developing what we feel is the best combo.
Yeah.
But yeah, so this 2180, 1630 has been really, really nice. But yes, this casting is essentially just making one head. I mean, we can configure it with copper seats, steel seats, titanium or hollow stem, Inconel or steel, different spring packages and everything. So we have two different chambers that we run. So there's a lot of versatility there within the one casting.
Right. Very cool.
Yep. This one here is running another popular setup. This is our CID LT casting. We get this one in a semi-machine state, and then we'll do all the porting, valve job, guide work on that.
That's very cool.
So once we come off of the CNC, then we'll go down to the seat and guide area. So once we come off the CNC, this is a great example. It's a LF7 factory casting that's been CNC ported. We installed the guides prior to porting, so they're all profiled. We're now reaming the guides, and we'll finish hone it to size from the actual valves that are going in. So we set up and dial in the valve stem to guide clearance right here. Once that's been set up, we'll valve job the cylinder head in either which machine, either the 30 or the Rottler. Both are capable and are set up to do any cylinder head. So both very fine machines that will create a nice concentric quality valve job.
Yeah, very cool.
Once that is done, we'll go into our porting room. So these are all cylinder heads that are ready to be hand blended. So even though the CNC does an excellent job, we kind of just go that last little step, hand blend in the the valve job to the port and the valve job to the chamber if needed. That's all done. We've got the downdraft tables, and we do all that grinding in there. Once we've hand blended the valve job into the ports, we'll come over here to this Rottler surfacer. This is set up specifically just to machine cylinder heads. You can get the fixturing to do blocks, but we just do cylinder heads only to make just for efficiency purposes. Since we have another machine here, it's a pretty cool machine. You can you can set it up to run like hand programs. Say you're taking 30 thousandths off of the deck of the head, it'll come in, take say 5 a pass until the last pass, then come take 2. However you want to set it up. So really nice. We'll dial in the the chamber volume here. Finish deburr everything, and then we will go. We'll final clean. And then go into the assembly room for cylinder heads.
Cool.
So this is where we assemble the cylinder heads once everything's been final cleaned, deburred, ready to go. Checked out. We'll bring it in here. We have all of our retainers, locks, locators, everything that we might need to set up a majority of the setups we have. We've really dialed it into say 5 different spring combos that'll handle everything from a hydraulic, a 650 lift hydraulic roller to a 1-inch plus lift drag race setup. Set them all up. We set spring pressures up on each. We pull all the springs, so we use a ton of valve springs for, let's say, a hydraulic roller application, or any of them. We'll sit there and we'll pull. Say we have a box of 400 valve springs. We set them up to where we kind of dial in their coil bind height. Sometimes they're not matched as closely as they could be if you have a selection of hundreds of springs. So we'll get each set of 16 to coil bind as close as possible. So when we do go to set them up, everything is as consistent as possible. So it's kind of nice. We'll just sit here and pull springs for a few hours and get everything box lined up, so we can pull it out and say, okay, this is 100, 1080, whatever it is in terms of coil bind. So once that's dialed in, then we can you know, it just improves efficiency and again, the consistency of the product. That's what's the ultimate goal through all of this is just the consistency from cylinder head to cylinder head, engine to engine. You know, where we know we're sending out the product where it should be.
Right, absolutely.
Everything's documented, of course. You know, we do a build sheet for all of our engine builds, cylinder heads only, so we can look back up. Hey, what shims is, you know, what do we have for shims, intake, and exhaust? What's actually in that? All the clearances.
And to that regard, how often does a customer dictate, you know, what gets put in the engine versus, you know, you guys saying, hey, here's our combos, here's what we know works for.
Yeah, we really try to make recommendations to the customer. You know, there's really no reason to deviate from our proven stuff. You know, it's but you know, we're open to suggestions. If a customer wants to do something new and different, then we'll pretty much tailor the components that we feel is necessary for that to achieve those goals. You know, without a doubt, you know, if every once in a while customers, you know, supply a part or two, and that's the you know, that's where things start getting hairy sometimes.
I assume it still has to meet your expectations.
Of course.
Of quality.
So we try not to do that. We limit that as much as possible. But if it's a part that we typically use, then, you know, it's fine. It's when they start trying to send custom pistons and, you know, things are not working out. So throughout the engine building process, the cylinder head department and engine department work hand in hand to be on the same page of not only the timing of the cylinder head. So when we go to the assembly room, you know, we'll have a set of cylinder heads that are done, ready to go. If it's more of a race combination where we have to specifically check, you know, say push rod clearance and piston valve clearance, or something is really critical on that combo, the cylinder head department will work alongside the engine department to finalize those critical things, then come back and assemble. So it does make for a nice combo when we have control over the whole thing, but also those two departments are working in unison to make sure that the cylinder heads going on that particular race engine are designed.
A little bit of checks and balances.
Of course,
very good.
Exactly. And then that, again, with the CNC department, so the more custom the engine, the more we have, you know, more discussion and consistency throughout.
Right.
Anyway. So from there, we'd go into the assembly room. I showed you what that's all about. I can show you some of the CNC machining that we're doing. A couple LT2 engines. We've been doing a lot more, especially with the release of the Global B software coming out. LT2s have been really catching on. So this is something that we're looking to do a lot more of. There's a new Herco. We just got a new 5-axis for porting of cylinder heads. So this machine, really, we've only made a couple test cuts with it, and we're waiting on a couple little things for fixturing and such to get it actually going. Here we're making a run of our LT timing chain guides. I don't know if you're familiar with this product.
Absolutely.
So that's how we're doing that. So we make 5 on each little rack there, and then they get split off.
That's super cool.
And then we machine the Delrin inserts on a different run, and then basically assemble. So.
Looks like something Batman would have in like a utility belt or something.
Right. So that's running that right now. This is running runners for, this looks like our LS7. So it's our LS7 billet manifold. That's first operation on the runner. So once this fixture has a first op and a second op. So once we machine one, we'll flip it over, and we can then run the second op. So each time we come off the machine, one finished runner will come out. So he just ran first op on this one and running second. So been good. That's the block that it starts with, and as it progresses. You want to scoot through? I'll show you over here. Maybe you can sneak a peek in here.
So this is part of the billet block?
Yeah, so this is our billet block program. This is running an LT2 for a C8 Corvette. So it's a new product that we were working on. So guys that are looking to take their C8 to the next level.
Yeah, that's awesome.
That's going to be our
you guys got to be pretty excited about that.
Yeah, we are really excited. We've got a couple unique things that we're doing with this block. The way that we are passing the water through the block, so we have a unique design that we're excited to be able to, present to everybody here soon enough. So it's pretty neat. We're looking to. I think it's going to be a good deal.
And you were saying that you might have one of those at PRI this year?
Yeah, we're going to try to bring this one to PRI. Yep.
All right. Very cool. So Bryan, with all that billet aluminum that you guys have come to the shop, what's that process like for buying the raw material? Like, how far out in advance are you guys on some of that?
Yeah, so usually to get the right forgings and everything for the material, it's about 6 months to get the material for the block.
Yeah.
All of the other aluminum that's available is pretty readily available. We have a couple sources around the country to get all the material, the plate and extrusions we use for our different products, either from Michigan or here in Texas.
Okay.
That's pretty easy. Maybe say 1 to 2 week lead time depending on. So that's pretty straightforward.
Yeah.
But yeah, we're bringing in thousands of pounds of aluminum each time.
Yeah.
We're just getting going, making some parts in the lathe too. So this is a new piece for us.
Yeah.
We've been making some gears for the Godzilla project that we're working on. So last year we debuted a front cover for the Godzilla engine that gets rid of the factory oil pump and also has the ability to run a distributor. You can run it with or without the distributor, and we're actually making the crank and cam gears in this machine here.
Okay.
One of those things that during the development of it, we were going to outsource it, and we just figured that it would be easier for us to control that internally.
Yeah. Very good.
So opens up a whole nother realm of we can do round parts now.
Yeah.
This is actually so we're coming on and off the machine, dialing in the whole process. But this is the front cover that has a distributor water neck we made to make it all work. And we're about to put this on the dyno. We have a cam in it. We ported the heads, so we're just basically taking the factory crate engine and kind of doing a heads cam and to test out our front cover.
Yeah. Oh, it looks awesome.
So just doing continuous development on that.
Right.
2 more Haas 4-axis machines. This is machining some Godzilla valve covers. So valve cover with the coil mounts on it. Okay. So that one runs all the time, and then we use this machine to do a lot of our new development work. So once we prove it out here, these kind of are production machines, and this is more of an R&D machine. This is we're machining the runners for the Hemi. Okay. So for the new Hemi, this is like a Hellcat 6.2, 6.4. This will bolt to a 6.2 or 6.4 cylinder head and is our race manifold. So we have the same, it looks like our standard race manifold, tall. We have different options for like 123 down to a 103 throttle body. So this one we're going to offer as a 108, I believe is the number. Okay. That Nick Williams, they make a nice throttle body for the Hellcat. We're going to have a flange for that, and then you could also run a single 123, like the Wilson 123 5-inch bore, mechanical throttle body. So this is literally the first one. We're making like 3 or 4 sets of runners. We're excited about this. So we've got a lot of guys that have original Hellcats, but they're getting rid of the blower and going turbo. Yeah. And this is our solution for that.
Very cool.
It's going to be killer.
Yeah. It's awesome seeing all the different stuff you guys have going on. Dude.
So you can see. So it hasn't run, we haven't run the port program through it yet, so this is right off the machine, and then since the way that the port has to be shaped, we're going to do the final port, the interior of the port in the 5-axis.
Very good.
So this will all get parted off, drilled and tapped, then once it comes off of there, it has dowel location holes. It'll go into a fixture into the 5-axis, do the port all the way through, deburr it, and it'll be ready to go on the manifold.
Yeah, very cool.
Yeah, we're looking forward to this.
Yeah. So Bryan, I was asking you earlier, I think before the camera started rolling, you know, is this kind of your forever shop? You know, what, you know,
yeah, so
where do you go from here?
Right,
Type
so
of thing.
when we moved in, I think we've been in this location for about 5 years now.
Yeah.
And, you know, when we first got in here, it was like, holy shit, this place is huge, you know? And coming from our original location, which was 5,000 square feet total, to a 17,000 square foot facility was awesome.
Yeah.
And 5 years later, we're busting at the seams, man. So we have the ability to do another 15,000 square feet off the back.
Okay.
So that's going to be our next move, and we're just gearing up to do that. So that'll allow us to move a lot of our manufacturing into the new location, into the new area. It's going to be a continuous spot. You know, it's right on this property here.
Yeah.
Move that stuff down and then give us more room to execute actual, you know, the engine side of things.
Yeah.
So it should be really nice.
Very cool.
So we're looking forward to that. Yes, sir.
Yeah. Awesome.
Last thing, I guess I'll show you the dyno. You know,
Yeah,
so
perfect.
once we've come from the assembly room, of course we'll come back to the dyno. We've got a Dart 427 with our Brodix BR3 heads about to go on. You know, we'll run the 1002 sensors, so one in each primary tube, one in each collector. Allows us to dial in and air-fuel ratio per cylinder. We can look at fuel, you know, distribution in the manifold. So when we're developing a new manifold, we can know that we're getting, you know, as equal distribution as we possibly can out of that piece. Run a blow-by meter, check for ring seal. We can run. We have a mechanical fuel pump, so it's kind of cool. We over the years that we've been running a dyno, we always had electric fuel pump issues.
Yeah.
I don't know if it's just because of the heat of the dyno or what, but it seemed like we're always in the most unopportune time we would have
something go wrong.
Fuel pump issue. Right. So what we do now is we run an electric fuel pump just to prime the system.
Okay.
We'll get it fired up. We turn that off, and then we have a mechanical fuel pump that we machined and made a little spud off of the back to run that mechanical pump. So it's not having to be driven by the engine accessories.
Yeah.
It's just driven by the dyno. So that's been killer for, like, we haven't messed with it in years and years and years. So it's really nice. And we can dyno, you know, well over 2,000 horsepower boosted. Yeah. And so that's been kind of solved our issues with the fuel systems on the dyno. Nice. So I appreciate you coming by to take the tour. Hopefully we're informative and gave you a couple of cool things to look at.
Bryan, that was awesome. I mean, like I said, 5 or 6 times, it's an awesome shop you guys have built up here over the 20 years, and very cool to see it in person. You know, the photos and the Instagram takeover doesn't really quite do it justice, but
I know,
we're trying here. We're trying to.
Definitely. I love the opportunity when a customer or somebody new comes in, I get to show them, because it gives you a good perspective of what it goes into building a high performance engine.
Absolutely. You guys definitely do it really well.
Cool,
and
man.
we appreciate you showing us.
Yes, sir.
Guys, appreciate you guys watching this engine shop tour, and I want to thank Bryan again and everyone here at Late Model Engines. Make sure you guys are checking out everything that they got going on. And as always, make sure you're checking out enginebuildermag.com for more great engine content. Thanks for watching, and we'll see you next time.